What happens if we drop a regular can into this water-filled tube? And what if we take a bigger one? Let's find out. Let's take a 7-Up can, drop it in, and boom, it shoots straight up. But what if we go bigger? Now, let's try a Monster can. It's bigger, heavier. Will it work the same way? Dropping it in. Whoa, this one behaves differently. Turns out, the size of the can affects how fast it rises. Water pushes it up, but weight also plays a role. Which can look cooler? What should I test next? Drop your ideas in the comments. Transition to the fire tornado experiment. We've figured out how cans float in water, but what if we try spinning fire into a vortex? For this, we need a cotton pad, some acetone, and a pipe with slits. We soak the cotton pad with acetone, light it, and place it inside the pipe. But it's important. The pipe should be cut unevenly, with small gaps, so the air can flow through and spin the flame. Let's start and watch what happens. The fire turns into a real tornado. Why does this happen? Hot air rises and the side gaps cause it to spin, creating a fiery vortex. Now let's create a smoke tornado. For this, we need a small piece of dry alcohol. It's important to use just a little, so the fire isn't too strong. Otherwise, the experiment might not work. Place the top half of a soda can over the alcohol and then drop a bit of vape juice into the bottom of the can. This liquid, apart from being used in vape devices, contains components that release thick smoke when heated. Now, cover the setup with the pipe that has gaps so the air can circulate. And let's start. Look at what we got. We created a real smoke tornado. Why does this happen? The heated liquid releases smoke and the gaps in the pipe make it spin, creating the vortex.
Wow!
Now here's a cool experiment that looks like magic but is actually pure science. We have 2 light bulbs. One is intact and the other has no glass. They are connected with wires, forming a circuit. I take a torch and start heating the filament in the broken bulb, and suddenly, the intact bulb lights up. How is that possible? The secret is thermionic emission. When the filament gets hot, it starts emitting electrons, creating a current that powers the second bulb. This is how fire turns into electricity. We just learned how to light up a light bulb with fire. Now, let's see what happens when we put different objects in the microwave. Ready to see plasma and fire appear right before your eyes? Let's start with the light bulb. We place it in the microwave, and once again, it starts sparking, creating plasma. This happens because the microwave waves heat the metal, causing electric arcs inside the bulb, which creates this stunning effect. Now let's take a grape and put it in the microwave. What do we see? Suddenly, sparks and plasma start to appear. This happens because the microwave waves make the molecules inside the grape interact, creating high temperatures and voltage. Let's try a marshmallow. We place it in the microwave, and it just puffs up and increases in size because the microwave waves heat the air inside, causing it to expand. We take a candle, insert a match into it, and place everything in a glass jar. When we turn on the microwave, a real wonder happens. The candle ignites, and plasma forms on top of the jar, just like sparks from a flame. This occurs because the microwave energy heats the air and supports combustion. Steel wool. When we put it in the microwave, it starts sparking and catching fire, creating real flashes. This happens because the metal heats up to such high temperatures that it triggers these effects. Short educational insight. How did you like these experiments? What would you like to see next? Drop your ideas in the comments and don't forget to subscribe so you won't miss more amazing experiments.